there's a high point and there's a low point. The vertex can be the highest or the lowest. A couple more seconds for you guys to get just the basics of this page down. But a lot of vocab going on, linear programming, graphing, analyzing lines, systems of inequalities are going to be applied, 7.5. For those of you guys just joining the video, my whole whatever webcam stopped working a bit. So I'm showing you what we went over today. We went back on in section 7.5. We did an example over here to the side of taking it piece by piece, graphing each inequality, shading each, and finding an overlap. We then have these vertices that won't show up in the calculator, but they will show up in the solution. Vertices are the corners or the intersections. But now we're basically getting into 7.6 in order to try to apply these systems of inequalities. Thanks, guys, for letting me do that. Here we go. So 7.6. I know. There's a lot of wording on this page, but once again, just please realize it's not a huge topic. Well, it isn't. It's actually a very huge topic. It's not one that we're camping out on or going very deep on. So linear programming, it's an optimization strategy. Optimization is trying to find the optimal solution to some sort of problem that you're being given. You have an objective. I mean, some of these terms are just English, right? You have an objective, you have a goal, you have something you're trying to meet, right? And so the objective function, at least for our case, these are all going to be z equals, which is weird, I know, x, y, z. We did three-dimensional systems in section 7.3. I'm not talking about that kind of z. I'm just talking about this extra out there. If we're talking about lines, we're talking about two-dimensional lines at this point with x's and y's only. So z is just an extra letter we get to use. Objective function. It's apart from the constraints. What's our objective? What's our goal? To make the most money. Okay, cool. How do you make money? By selling a product. Okay, cool. How do you get a product? By stealing it. No, that's not having integrity. By making it. Okay, now you have cost. Can you do it by yourself? No, I have to hire people. Oh, now we have more costs. Can you do it in your house? Nope, I have to rent a space. Okay, now you have more costs. So how about that whole profit thing? Okay, so anyway, you have an objective. I want to make money. Cool. How are you going to make money? Well, I'm going to sell products at this price. Cool, but you have all this underground information that you have to analyze. Okay, that's kind of the idea. The objective is big, it's bold. You're not going to really see it because it's just going to be like a random equation that has a z, but okay. But underneath the surface, the iceberg. I want to make money. Cool, but what's underneath? Okay. There's all these constraints. And for our purposes, we're just doing linear programming. We're not bringing in curves. Curves would be calculus because we're talking about area. An area under a curve is called an integral. Go talk to a Calc A, B, or BC kid. We're just talking about lines. Area under lines we can do. Those are like triangles, rectangles, trapezoids. We can do that kind of area. And to be honest, we're not even going that deep to finding the area. But linear inequalities, hey, that's section 7.5. Will help us determining the feasible solutions. But the question is how. And that how is answered by the, right here, key to solving. And the key to solving is, if you have a linear system of inequalities, just look at the vertices. The optimal is going to be at one of those. Because inside the area is infinitely many solutions, infinitely many possibilities. Maybe not realistically infinitely many. You probably wouldn't sell your product for something like $5.11. That's awkward. But still, there are a lot of different possible points inside any shaded region. So the cool thing is we can just look at the vertices, look at the corners that are formed by the overlap and say, hey, the optimal is one of those. And once we shade section 7.5, once we take what we have and shade it, once we find the vertices, all we have to do is test the objective and say, you know what? The highest, the lowest is going to be at one of those. The highest, the lowest is going to be at one of those. Do you want the highest? I'll plug them all in and I'll tell you the highest. Do you want the lowest? I'll plug them all in. Not all, not the whole shaded, just the vertices, that's all. We just talked about how the vertices are found by the intersections of the lines that are contributing to, well, my way of saying it, the shaded overlap. Or region of the system of constraints, the feasible region if you want to be super snazzy. So here's the steps. Part 1, sketch. What? Do section 7.5. Get it all in the picture and find the overlap. Step 2, find the vertices. How? Intersections. Step 3, plug them in. To where? The objective. And do what with them? Well, find what you want. Do you want the highest? Give it that one. Do you want the lowest? Give it that one. Just a quick little note. It is possible to tie. It is possible to arrive at the highest or the lowest in more than one place or with more than one situation. It is possible to tie. It won't always happen. Just have a dry throat today, sorry guys. It is possible to tie. It is possible for the max to be reached at more than one, but the point is, if the max is reached at more than one, the max will still be one certain quantity. There just might be more than... How can I do this? In English, you usually write it and then put a little S after, but vertex and vertices, you spell them differently. Well, I'm saying it's possible to tie. If it's possible to tie, then I would be at... If I'm talking about the ties, I'm talking about multiple vertices. So the max, the certain max, might occur more than one way, but you'll still know the highest that it can go. It meaning the objective, which might be indicative of like profit. One max, but it might be at more than one vertex. All that to say. I'm going to do one. I'm going to do one that's just like no words. No practical application. Your objective is z equals 3x plus 2y. What am I trying to get? I don't know what it means, but I'm trying to get this thing. What about this thing? I'm trying to find the highest of it. Okay. What's going on? I don't know. Just the math. This one just kind of is like, here's the math to the problem. And then, if we have time, we'll peek at one with words. We'll peek at one with words. And just a quick little, like, just planting a little seed in your brain. The test could make one of these problems a whole lot easier if the graph was already done for you. Because half the work is just getting the graph. Half the work is going back to section 7.5 and saying like, I have to figure this out. But can I give you one huge hint? Whenever we see x greater than or equal to 0 or y greater than or equal to 0. That's always just going to be, hey, only look in quadrant 1. X is positive, y is positive. Forget quadrant 2, forget quadrant 3, and forget quadrant 4. And in real life, it might make sense why this is very common, because usually you're only talking about positive objects. I mean, money can go negative. Let's not go there. But we're usually only talking about positive quantities, not negative quantities. Not saying you can't have loss, but that's different. Anyway, so we're just looking at the first quadrant. So the cool thing is, I don't even have to graph these first two, because it's just saying, hey, keep it positive. I'm like, sweet, no big deal. I'll only graph in quadrant 1. Now I'm going to go ahead and talk about these two guys. However, the sad thing in both of them is, I know, y is not by itself. But even to use your calculator, you have to get y by itself. So I'm going to get y by itself. Mental mathers, just double check my math. I believe I get negative 1/2 x plus 2. Which I'm going to graph as you guys double check my math. Maybe I should have you double check it first, but that's okay. I'm going down 1, right 2, down 1, right 2. And I'm only graphing this part because I'm keeping in the first quadrant. Sorry, pretend that's straight. Mental mathers, was that good? Subtracting x dividing by 2. I think I heard someone back me up. This one's going to be y is greater than or equal to. I'm going to add the y, subtract the 1 because I'm lazy like that, but I still need to be efficient. Or you could subtract and divide by a negative and flip the sign. Even sounds harder. But when I come down here to graph, my rise over run is going to be 1 over, hey, they intersect and I just found it because I graphed carefully. The intersection is going to be at 2, 1. My shading, if I was to think about it, well, actually, can you guys just think about it with me real fast? I'm sticking in the 4th quadrant. The green is below, the red is above. Where's my overlap? vertex, 2, 1. Do you guys see any other vertices that just naturally we can know by graphing? Isn't one vertex going to be the y-intercept, which was 2? Do you see the y-intercept? Are we okay? I mean, I can just throw in answers and trying to make sure you're tracking. I graphed the green, I shaded below. I graphed the red, I shaded above. I graphed using good old-fashioned y equals mx plus b. I'm looking for my corners. My corners, 1, 0, 0. We can all agree with that one, yeah? So wait, what did you say this one was? 0, 2, good. Because I knew the intercept of my green, which kind of stops it from going to the other quadrants, was 2. What's this guy going to be?
1, 2.
Yeah, but we have to kind of think about that one, right? Because it's when y equals 0, so I could plug in, I could solve, or I could check it and see, oh, I went up 1 over 1, so yeah, 1, 0. So how many vertices do I have? What do I do once I sketch 7, 5? Once I find my vertices, got my 4, now what? Test. Where's my objective? I don't know what it means, but it's right there. So how do I test it? Plug it in. Yeah? When I plug it in, I just take my vertices one at a time. My 0, 0, my 0, 2. The order doesn't matter. It's just whether or not I can make the right match. Some of you might guess that 2, 1 is probably the highest. You could go straight there. Be careful in context of the problem. There are times when what you expect is not necessarily what is true. Talk to a BC kid about convergence and divergence of infinite series. But when I plug into my objective, 0 plus 0, plugging in 0, 0, well, that's not very high. 0, 2, 0 and 2 times 2 is 4. Okay, that's better. 1, 0, 3 plus 0 is 3. But 6 plus 2 is 8. What does this tell me? I know the maximum objective, or the highest the objective can go, is going to be 8, which is going to occur. I put the word at, that's a very common mathematical way of saying, like, for what values of the variables. But the maximum of 8 is going to occur at, or when, x equals 2 and y equals 1. Now, to try to illustrate that, you do not need to write what I'm about to show you. To illustrate that, if we were to take this region, and if we weren't to plug in the vertices, if we were to start putting in random points in between with fractions and decimals and all that sort of stuff and say, okay, really? Like 8 is really the highest? I have so many points I can try. We could plug in some interior stuff and say, hey, how about 1, 1? How about 1, 1 half? How about 1 half, 3 halves? How about 3 halves, 1? We can try plugging in all these ones. But guys, you're never going to go above 8. The max or the min will always occur at a vertex. And even if there's a tie, it never will tie with interior points. If anything, it'll tie with maybe boundary points or other vertices depending on the slope. Which, once again, you don't have to necessarily ever plug in interior points. You can take me at face value and say, okay, only the vertices. If I test those, I'm good. But the reason why I talk about the slope is because technically there is another way of looking at this problem. The z equals the objective. We could have actually gotten y by itself with the z, kind of like into or inside the mx plus b equation. And when we put it inside the mx plus b equation, this z is technically a part of the y-intercept. But it has to have a slope of -3 halves. Another way of doing this is actually to go ahead and graph all sorts of lines with -3 halves and see how high this line can go and still hit the region. And the highest this line can go and still hit the region is at this vertex that we figured out is the maximum that leads me to this intercept of 4, which leads me to a z of 8. But that's way more graphical, way more geometric, way more complicated, I would say, than just solving it by testing and going through our steps, trying to figure out what is our objective, what's the highest it can go, and using, let's get back to the example, just the vertices to get there. I'm going to actually go ahead and delete these 2 pages because they are not that crucial to understanding what's going on. And I'm about to delete this one also. No, I'll leave this one in, but you don't need to write it down. Because with any mathematical process, there are weird, unknown, or unusual solutions that can occur. And one of those unusual ones that can happen is if that slope happens to be exactly a boundary, then the max will occur not just here and here tying, but also it could occur at any of these values. But for our purposes, guys, I just want to know, can you find the max? Can you find the min? I don't really care if there's a tie or not. I just care whether or not you can see what the highest is the objective can go, or the lowest, using this whole, let's sketch, let's overlap, let's find corners, and let's plug in. So what happens when we get words? Okay, I just said that we could at least peek at a word one before we're done. What happens when we get words? What is a lot sadder, besides there just being words? What makes this harder? Okay, words with numbers. What don't you have that you really wish you could just to start going right away? I wish we had the system. We have to find the system, to graph the system, to find the overlap, to find the vertices, to plug into who's the objective. I don't even know who the objective is. Yes, you do. You just kind of were able to speed read. I want to find the maximum monthly profit. Well, wait a minute. I don't even know how I make profit. Yeah, you do. You read through it. Box of chocolate creams, that's $1.50 per box that I make. And a box of chocolate covered nuts, that makes me $2 per box. A profit of. That doesn't mean that's the selling price. That's after you are consider the cost, the overall profit. So I know my objective. My objective is $1.50. I guess I must be making the creams X. And then $2, I must be making the chocolate covered nuts Y. But still, what am I missing? Now the nice thing is, I'm not going to go looking or making negative boxes, so I can kind of do that whole first quadrant thing right away. And I'm only having positives, first quadrant. But then do you guys see how I have other constraints that I have to consider as given to me by the problem? Like, the combined production level should not exceed 1,200 boxes. Maybe your shipping company can't really handle more than that, or you don't want to spend any more shipping costs than like 1,200 boxes. Or maybe your factory can only store up to, I don't know why. Honest Precalc wanted to know why about everything. But combined production level, that means that all the boxes of X and all the boxes of Y's need to be less than or equal to 1,200. Can't go above that. The demand for a box of chocolate covered nuts is no more than, so this guy, no more than half. Creams are more popular, huh? Guess I should probably consider that. Production level for chocolate covered creams should be, production level for creams, that's this guy, should be less than or equal to 600 boxes plus 3 times. I have to work through the wording to get the system to work. Now, do you see these numbers? Could you do it by hand? Yeah. Would you have to? No. Use a calculator. Told you you could use it on the whole test. But do you see how you need to get these maybe in some sort of form that you could actually graph the line? And then this one, okay, that's red, and graph the line. And then this one, well, hopefully it wouldn't take you too long. Minus 600 divided by 3. Maybe the numbers aren't that bad. Maybe I wouldn't have to be that scared of this. But what would you need to do to finish? I'm doing all the work. I'm just trying to show it to you. I'm not making you guys like go crazy. You're just trying to see if you can follow the flow of how I'm solving it. Where would I go next? Now that I have my system and now that I have it in a way that I can graph. See it? Who am I going to graph? This guy. Intercept of 2, 4, 6, 8, 10, 12. 1,200. This guy. He has an intercept of -200. Rise over run. Aw, I don't want to go by 1s and 3s. I have 200s. Okay, go by that. Can't I go up 1 200 and go over 1 2 3 200s? That's 600. I might be able to use that for a vertex in a second. Can't I go up another 200 and over another 1, 2, 300, which will land me at 1200. I have this guy. I need to stay above that guy. My red one, well, let's go to this one. He looks easier. My blue one, I need to go down 1 over 1. So down 200 over 200, down 200 over 200. Oh dear. Down 200 over 200. This is tedious. Maybe I'm just going to graph it and be like, you know what, whatever. I'll find the intersection. I can do that with math. I can take the green and the blue and figure out where these two intersect using my 7172 skills. We'll find that vertex in a second. This guy's shading below. Shading above, boom, shading below, got it. All I need is red. Red has an intercept of 0. I go up 1 over 2. Up 1 over 2. Ooh, that's interesting. So what's below the blue, above the green, and below the red? I think I see my region as this. Only that stuff that's in the first quadrant. And I can say, hey, 0, 0. Blue and red intersection, blue and green intersection, and then this guy is 600. Well, at least I know 2 of them. So I can use 600, 0 as one guy I'm going to plug in. I can use 0, 0 as another guy, and I'm going to review how to solve for intersections to find those 2. I'm going to take them all. I'm going to say, hey, what was that profit thing again? And let's plug in 1, 2, 3, 4 points and say, who's the highest? With this whole huge problem, what's the maximum profit that I can figure out? Or that I can do? Guys, that's 7-6. You have about 20 seconds just to kind of detox. Take a couple deep breaths before you get positioned to go try to re-energize before finishing out this Friday. I know you're tired. I know you're out of it. Maybe you're excited for movie night. Maybe you're judging. Don't judge. Come out and have fun. Be a kid. But otherwise, homework this weekend. I think we'll have 10 close and have fun. And 7-6, has anyone looked at it? How many problems are from 7-6? You got this. Yeah, I'll see you guys later. You got this. Not even all word problems. Did I give you any? Bye guys, happy Friday.